Okay, so next is design of spiral columns. So ito yung mga formulas na involved sa spiral columns. Na-discuss ko na din ito sa previous na video. So ngayon is mag-design tayo ng spiral, actually loaded na spiral column. Okay. So design around spiral column to support an axial lead load of 800 kN and axial live load of 1,350 kN. So assume that 2% na longitudinal steel is desired. Then yung FC prime is 27.6 megapascal and then yung Fy is 414 megapascal. So use 25 millimeter main reinforcement and 10 millimeter diameter na spiral with 30 millimeter steel cavity. Okay, so yan. So alam natin yung ultimate design capacity ng column is just phi nung nominal, where yung nominal for spiral is just 0.85 nung PO, no? Or this becomes phi nung 0.85 and then we have 0.85 nung FC prime, area gross minus area ng steel plus yung Fy area nung steel. Okay? So, dito yan. Kung babalikan natin yung formula, ito yan. No? So, yung phi dyan is 0.75 both 2001 or 2010 or 2015. So, the same lang sila ng value. No? Kasi yung nakalagay sa NSCP is 0.65 to 0.9. Okay? Okay, so kunin muna natin yung PU. So, yung PU is just 1.4 nung dead load plus 1.7 nung live load. Okay, so we have 1.4 nung dead load, we have 800 and a live load of 1350 kN. So, we have 800 plus 1.7 times 1350. So, yung sagot niyan is just equal to, kupitin ko muna. So, this is, so for 2010, yung PU is just 1.2 nung dead load plus 1.6 nung live load. So, ito lang yung load combination natin kasi yung given lang is dead load tsaka live load. Okay? So, we have 1.4 times 800 plus 1.7 times 1350. So, yung sagot is 3482.5 kilonewton. So, this is based on 2001 NSCP code. And dito naman, we have 1.2 times 800 plus 1.6 nung 1350. So, therefore, yung sagot nito is wait lang. May mali. Mali yung na-input ko. This is 3415. 3415. Okay? So, dito naman is meron tayong 1.2 and 1.6. So, we have 3120 kilonewton. This is based on 2010 NSCP. Ayan, no? So, meron na tayong value for the PU. Next is yung EST. That is steel ratio times the gross. So, assume daw natin na 2%. So, we have 0.02 nung gross area. Okay? So, thus, substitute na natin lahat. So, based on 2001 NSCP. So, meron na tayong 3415. And then, yung fee natin is dalawa. 0.75 lang, no? So, 2001, 2010, or 2015. The same value. So, we have 0.75 times 0.85 times 0.85 nung FC prime, 27.6. So, 27.6 times area gross minus 0.02 nung area gross plus yung FY na 414. So, we have 414 times yung EST na 0.02 area gross. So, thus, we have area gross. Okay, so computing ko muna. Kilonewton. Gusto ko maging Newton na lang to lahat. Kasi naka-Newton to lahat eh. So, 3415 times 10 to the power of 3. So, Newton na lahat yan. 3415 times 10 to the power of 3 alpha equal nung 0.75 times 0.85 times yan plus yan 0.85 times 27.6 times alpha x minus 0.02 nung alpha x. Okay, and then 414 times 0.02 nung alpha x. Shift solve. So we have 171 305.587 square millimeter. So, meron na tayong gross. For 2010 or 2015 NSCP code, so meron tayong 3120 times 10 to the power of 3. So, yung nagbago lang is yung load lang, no? Then, the same pa rin yun dito. 0.85 times 27.6 times area gross. 0.02 area gross plus 414. 0.02 area gross. Ayan, no? So, thus, we have area gross. So, palitan ko lang yung load dito ng 3120. Shift solve. So, I have 156,507.593 square millimeter. So, meron na tayong gross area. So, ngayon, makukuha na natin yung dimension nung section. So, for 2001 NSCP code, so I have area gross pi over 4 diameter squared. So, yung area gross is ito. Pahin ko na lang yan. Then, paste ko na lang yan dito. So, this is equal to pi over 4 diameter squared. So, thus, we have diameter. Okay. And for 2010 or 2015 NSCP code, so the same. Gross is just equal to pi over 4 diameter squared. So, yung area gross niya is ito. Kopyahin ko na lang yan. And then, ayan na, no? So, we have pi over 4 diameter squared. So, thus, we have diameter. Okay, so, computing ko muna yan. So, 171,305.587 alpha equal pi over 4 times yung diameter squared. So, we have diameter that is plus minus 467.03 millimeter. And then, yung isa is 156,507.593. So, that is plus minus 446.399 millimeter. Okay, so meron na tayong use diameter, say gawin ko na lang 470. Okay, so yan lang yung gamitin ko. So depende yan sa'yo, no? Depende yan sa'yo. So yung nearest ko na lang. Yung dito naman, use let's say gawin ko na lang 450 mm. Okay, so may 20 mm na diferensya nila, no? Sa 2001 tsaka 2010 or 2015. Okay, so ngayon is yung number of bars. So we have EST, that is phi nung AG, and this is equal to the number of bars pi over 4 diameter of bars squared. So same with 2010, so same formula. So substitute ko na lang yung value. I have 0.02. Okay, 0.02 times yung area gross. So gamitin ko na lang yung bago. Okay, so pi over 4, diameter niya 470 squared. Ay, di ko na gamitin to kasi based to sa 467. Yung bago na 470 kasi yan yung gagamitin ko. So we have n pi over 4. Yung diameter na ipagamit ng problem is 25 mm. So we have 25 mm. So meron tayong number of bars. So ganun din dito, we have 0.02 pi over 4 ng 450 squared. Then we have number of bars, pi over 4, diameter of bar is 25. So thus we have number of bars needed. Okay, so substitute ko na lang yan dito. So 0.02 times shift pi over 4. And then, gawin ko na lang alpha x squared. Diameter na lang, alpha d. And then, number of bars, yun yung unknown. Times shift pi over 4 times 25 squared. Shift solve. Calc ko lang muna. Calc is 470. Okay, so shift solve ko yan. So meron akong 7 bars needed. Okay. And then, yung sa kabila is 6.48. So, let's say 7 bars. So, same lang yung number of bars na kailangan nila. Mas maliit lang talaga yung dimension dito sa bagong code, no? So, nagiging conservative lang yung bagong code, which is maganda naman. No? Mas gamay mong magasto na. Okay, gamay mo ang kailangan nga volume sa concrete. Okay, so okay na tayo dyan. So next nating kukunin is yung spacing, yung spiral pitch. Okay, diyan na lang. Okay, so meron tayong 7 bars. So let's say ito yung bars ko yan. So yan 7 bars. So paano ko siya? Dito na lang. Let's say 1 2 say 3, let's say 4, let's say 5, 6, let's say 7. So assuming ganyan na lang yung arrangement, no? Okay na yan? Okay na yan. Okay, so ngayon kukunin natin yung mga section naman ito. Lalagyan ko muna siya ng spiral loop dito. Okay. So yan, no? So yan na yung loop natin. Okay, so ngayon kukunin natin yung core nya, yung dito, and then dito kukunin natin yung core. Ayan, so meron tayong cover na binigay sa problem na 30 millimeter. So 30 millimeter yung diameter, yung covering, hindi yung covering, rather yung covering. So we have 30, and then dito 30. Okay, and then dito naman meron tayong dimension na 2001, 470. Let's say ito yung 470, this 2001. Okay, so ngayon makuha natin yung core diameter niya na 470 minus twice no 30, and that is just equal to 410 millimeter. Okay, so ibig sabihin masosolve na natin yung area ng concrete core, no? So lagyan ko na lang to. So makukomplete na natin to, yung area ng concrete core. Okay, which is ito yan, yung shaded na yan. So area nung concrete core, that is just pi over 4 dc squared. So that is just pi over 4 nung diameter 410 squared. So yan na yan. And for the gross is we have pi over 4 diameter squared. So we have pi over 470 squared. So kunin ko na lang din yung area nung spiral, yung AS na maliit. So that is just pi over 4, and then yung ipagamit niya na diameter nung spiral is 10. So 10 squared. So yan na yan. So I think okay na tayo dito lahat. So kunin natin yung formula for the minimum steel ratio. So yung PS minimum is just equal to 0.45 area gross minus area ng concrete core minus 1, and then FC prime all over yung FY. So thus we have 0.45, okay, times pi over 4 410 squared all over area gross. So this is 470 all over pi over 4 410 squared minus 1. Yung FC prime natin is given. So yung FY, so we have 27.6 all over yung FY na 414. Okay, so So, yung sagot nito is 0.00942. Okay, so bali dito is ito yung sa FYH or yung FYT. Yan yung sa yield stress nung spiral, no? Take note, we are considering spiral na dito, no? So, yung spiral yan. So, since dito wala siyang binigay, yung FY kasi is per main bars. So, since wala siyang binigay na FYT, so assume na lang natin na yung FY tsaka yung FYT or FYH is the same, no? Pero dapat hindi talaga the same dapat yan, no? Kung kukonstruct ka, dapat mas weaker yung spiral na yield stress niya kaysa dun. Mas malaki dapat yung FY ng main bars kaysa dun sa secondary reinforcement. Sige. So, ngayon, makompute na natin yung spacing nung spiral. Okay? So, gagamitin na lang natin yung formula. Okay, so meron na tayong PS, that is 4ES yung formula. DC minus DS all over yung S DC squared. So, therefore, we have 0.00942 yung nakuha natin dito. And equate na lang natin to ng 4, and then we have pi over 4. Diameter nung spiral is 10, and then diameter nung core natin is 410 minus diameter 10 all over yung S, and then diameter nung core squared. So thus we have spacing. Okay, so computing ko muna yan. So we have now 0.00942, and then we have 4 times shift pi over 4 times 10 squared, and 410 minus 10, and then alpha x times 410 squared. Shift solve for x, 79.358 mm. Okay, this is on center. Okay, so say na lang natin na say 79 mm on center. So kung ito yung parang natin spiral, so yan, no? So ito yung sa gitna niya, no? Yung gitna nito, ito yung gitna dito. So yan yung S. So yung clear spacing is yung ito, tsaka dito. So ibig sabihin yung dito na part, yan yung diameter ng bar divided by 2. Then yung dito na part, yan yung diameter divided by 2. So ito yung S clear. So S clear will be 79 or yung S minus diameter nung spiral. So we have 79 minus 10. So we have 69 millimeter clear. Okay, so we need to check that for code requirements. So yung code dapat in between lang siya nung 25 tsaka 75 mm. Okay, so since greater than siya ng 25 tsaka less than siya ng 75, so okay gamitin yung 69. Okay, so I hope klaro tayo dyan. So yun na yun, no? So we have now the spacing na 79 mm on center. Okay, so that is for 2001. So how about for 2010, diba? So, the same pa rin yung process, no? So, kayo na lang yung mag-compute nung 2010. Okay? So, same lang yan. Yung magbabago lang is yung dimension. Sige, so see you in the next video. Thank you.